So welcome back. We are now on lesson number 6, I believe, our 6th lecture. And does anyone recall what we ended up on? We were working on the normal distribution, standardizing, and two-scores. Do you mean z-scores?
I think we're on slide 17.
Slide 17. That's what I thought. Okay. So let's just recall what we've done so far. We first, that's funny. Okay, so we first talked about density curves in general and distributions. A distribution is an approximation to reality with a smooth curve. We spent some time speaking specifically about the normal distribution, which is arguably the most important of all distributions. And we learned the very important 68, 95, 99.7 rule, which is very aptly named and essentially tells us what percentage of the data we expect to fall 1 deviation out from the mean, 2 deviations out from the mean, 3 deviations out from the mean. And with that knowledge, so one second. Hi, Professor, just making sure, when does the chapter 2 homework due? Sapling says it's due tonight at 11 p.m. Well, we finished it last week, a week ago. So yes, it's due today by 11 p.m. So the chapter 2 homework is due tonight. And that reminds me I should put up the chapter 3 homework since we're going to finish chapter 3 today. So I actually got myself a planner, CSUN Academic Planner. And I'm going to turn to September. Do you guys all have planners? I haven't had one of these since I was a kid. Today is September 10th, Thursday. So, math 140 science, assign chapter 3 homework. So that's now on my to-do list for today. Oh, wait. Okay. So where was I? Yes, the 68, 95, 99.7 rule, which then allows us to determine how much of the data or what percent of the data we expect to fall between this point and this point, and between that point and this point, and so on. Then we talked about standardizing. And standardizing is the essential concept that every single normal curve in existence is technically different. They have different means, and they have different spreads, different standard deviations. And as such, it's hard to compare values that fall in 2 different distributions to each other. So what we do is we standardize. We convert to the standard normal distribution. So let's recall our notation that we've been using. So we have the n of mu sigma notation. This tells us 3 things. What does the n tell us?
The mean?
No, the n.
The number of values?
No.
Normal.
That it's normal.
Normal.
The n tells us that we're dealing with a normal distribution. What is mu?
Mean.
That's the mean. And what's sigma?
Standard deviation. Standard deviation.
That's the standard deviation, right? So the n of mu sigma tells me 3 things. N, it gives me the shape. Mu, it gives me the center. And sigma gives me the spread. So what we do is we convert this to the standard normal distribution. And the standard normal distribution is also normal. It is a normal distribution. That hasn't changed. But it's a very specific normal distribution. It's specifically the one where the mean is 0 and the standard deviation is 1. And how do we convert it? we take our data point x and we convert that data point to z. X is our data, and we convert it to a new number z. And what's the formula for z, or the z-score? What's the formula? Z equals, we did this, correct?
X minus mu over sigma.
X minus mu over sigma. So we take the data point x, we subtract the mean, and we divide by the standard deviation. And when we do that, we go from having a normal with any mean and any deviation specifically to the standard normal where the mean is 0 and the deviation is 1. And because every normal can be converted to that one, then it's very easy to compare two different values that we get from two different distributions. We just see where they fall on the standard normal distribution curve. We'll do an example of that. Okay, so let's now look at slide 17. And we'll start with the following problem. Well, actually, let's go to slide 16 first. I don't think we did slide 16. If we did, then it's not horrible to repeat it, but slide 16. So, well, we didn't do it. Okay, so what we're quite often interested in is a situation where you have a normal curve and you have some value x, and we're specifically interested in the area to the left of that point. So we want to know what percentage falls to the left of x for a specific normal curve. In other words, we are accumulating all of the possibilities up until x. And we call this the cumulative density or cumulative distribution function, the CDF. We want to know what is the accumulation of all of the probability or all of the proportions or all of the percents or all of the possibilities up until that point. Now, if it falls exactly 1 deviation down, 2 deviations down, 3 deviations up, then we can use the 68, 95, 99.7 rule. Unfortunately, that's not always going to be the case. So let's do an example to illustrate. And then what I want you to do is I want you to skip slide 17 for a second, because I'm going to use slide 18 to illustrate this. And then we'll go back to slide 17 to demonstrate how we would solve this. But the question is as follows. Suppose you happen to have the N01 distribution, the standard normal distribution, and we're interested in, we know the center is going to be 0, and where it's staying -1 is here, and the same distance apart is here, and the same distance apart is here, and so on. And we want to know what proportion of observations are going to fall between -1.25 and 0.81. So we're interested in the proportion that fall between -1.25 and 0.81. And unfortunately, the 68, 95, 99.7 rule is not going to help us in this situation. So what I'm going to do is I'm going to load up, I'm going to share my screen for a second. So let me share my screen so you can see where I'm going here. Okay, does everyone see this, the z-score table?
Yeah.
Okay, so first look at the pattern. We have a normal distribution. We have a specific value, z, because z is what we use for the standard normal distribution. And we're having to the left of z shaded. And the question is, we're interested in the total proportion of data that falls to the left of z in the shaded area. So what we have here is we have a z table. Z is given by this column here together with this row here. These are the headings for the table. Do you guys all see what I'm talking about when I move my cursor?
Yes.
Okay, so that together, how do you move? Get out of the way. That together with that tells us where to go. Now, our first z value is negative 1.25. So we find a z value of negative 1.25. So negative 1.2 is there, correct?
Yeah.
But
Yes.
where's the point, where's the negative 1.25? I just have negative 1.3, negative 1.2, negative 1.1. How do I get to negative 1.25? I want the second decimal place. So where do I get this?
Between.
Huh?
To the right of the row.
Here?
Next. It's 0.1056
How do you know that?
because you look at the digits on top, which show the hundreds.
Okay, so the digits on top give me my next decimal place. So here I have negative 1.2, and that's the extra decimal, negative 1.25. I go where they meet, and I have 0.1056. That tells me that to the left of negative 1.25 is 0.1056, 10.56% of my data. Am I done with the problem? Have I answered the question? Have I answered the question?
No.
No, what am I missing?
0.81.
Well, I want between them, right? Not only am I not doing anything yet with 0.81, but the 0.1056 doesn't even answer the question, right? It might be to the left of that point, but I want between them. So what I need to do is I need to find a follow-up. First, let me clear my drawings. Now you'll notice that this is the second half of the table. This first half, the z was on the left, so my z's are all negative. But the other half of the table, z's are all positive. So what am I looking for? Which positive number? Which z value am I looking for?
0.81.
0.81, 0.81. So I go to 0.8, which is right here. And I want the second decimal place to be 1, which is right here. So 0.81, where do they meet? 0.7910. So that means everything to the left of that is 0.7910. 79.10% is to the left of that number. So how do I use those two pieces of information to answer the question, what percent is between them? How do I answer what percent's between them?
Do you subtract both values?
I subtract, right? The whole thing, take away what's on the left, and you should get what's in the middle, right? So it's about, 79 minus 69, 68 point something percent. Correct?
8.54.
Something like that. Let's take a look back at our PowerPoint. And what do they have as their answer? On slide
0.6854.
which is exactly what we get here. Now, the way they did it is technically a little different than how I did it. So we got the same answer, but they did it a little differently. Here's what they did. They said the following. They said, to the left of this number is 0.1056, right? They got that the same way we did. What's to the right of this number?
Point 2090.
0.2090, because remember, to the left of this number, to the right of this number, it has to be everything, so it has to add to 100%, right? So these two numbers have to add to 100%. Can you explain again how you found the values from the left and right of the middle portion? I'm not sure exactly what you mean. This number here, the table gave me that to the left is 0.1056. And this number here, the table gave me to the left is 0.7910, which means to the right is 1 minus that, because they have to add to 1. Can everyone make sure they are muted? Is anyone not muted? Is there anyone on the front page? Well, I'm not muted, but I hope you don't mean me. That would just be rude. Okay. Okay, he's muted now. Okay. Like, what did you do in the table? Could you be more specific? I don't know what you mean. And you can do it verbally if you're okay with that. I'm not sure what your question is. How did you find the values in the table? Well, let's go back to the table. Let me share again. So share screen and the table. So the first number there on the left is negative 1.25, correct? I can't see you writing now because I'm sharing my own screen, so you'll have to say it if you want to. But do you see that?
Yeah.
Okay. So you find negative 1.25. Here's a negative 1.2. You see it?
Yep.
And there's the 5, this next decimal place. So negative 1.25. I look to where they overlap, the row and column. And it's right here at 0.1056. Do you see that?
Oh, yeah.
So that tells me that to the left of negative 1.25 is 0.1056.
Okay, got it.
And then for 0.81, I did the same thing. I found 0.81, and I see that to the left of 0.81 is 0.7910. Okay, notice, by the way, I knew this table gave me the left because their picture told me it was left. Sometimes you might find online or in books to the right, in which case the details are a little different. The details are a little different, but the understanding should still be the same.
Okay, thank you.
You're welcome. So they did it a little differently. They did 0.1056 that way, 0.2090 that way. They added up those two, which are the outsides, and said, okay, 1 minus that will give me the inside, which is perfectly valid and just another way of doing it, right? So the details are a little different, but the final answer will still be the same. Does that make sense? I hope so.
Wait, I just have a question for clarification.
Yeah.
Wait, so I'm just kind of confused at where the one came from.
Well, the whole thing has to equal 1. That's right. That's rule number 2 of distributions, that the total area has to be 1. Right? The total area has to be 1.
Thank you.
Because remember what this is. It's all possibilities. right? All possible percentages, proportions. So it has to add to 100%.
All right, thank you.
Does that make sense?
Yeah.
Okay. So back to the PDF. So if we look at the previous PDF, now the previous PDF, the previous slide of the PowerPoint, I'm not sure what words I was using there. They came out all wrong. Just gives me exactly what I just described via my example. They want Z less than 0.81. So they found 0.81. They got 0.7910, exactly like we did. Okay, so we can now go ahead to slide number 19. And we can ask the following question. The combined scores of the almost 1.7 million high school seniors taking the SAT in 2013 were approximately normal, with mean 1,011 and standard deviation 216. And the question is, what percent of high school seniors meet this SAT requirement of the combined score of 820 or better? So here we have a picture. First, it's a normal curve because they told us that it was normal. So we draw a normal curve. What's the center of the normal curve? What number would be right in the center?
1011.
1011, it's the mean. And so 820 is somewhere off to the left, right? So they drew 820 somewhere off to the left. And they want the percent of high school seniors that are 820 or better. So they shaded to the right because that's what they're interested in, correct? Yes?
Yes.
Okay. So unfortunately, the table doesn't give me to the right. The table gives me to the left. So how do I use that information? Well, so they did it for me. They took the whole thing, which is 1, and they subtracted the left, and that gives me the right. Of course, how do they find the left? This is not a standard normal distribution. It's not a Z distribution. It's some other one. So how do I go ahead and do what they did here without explanation of telling me that the area to the left of 820 is 0.1873? So let's go ahead and do that. So we have a normal curve right here whose mean is 1,000, what was it, 1,011? Is that what it
Yeah.
was?
Yes.
And what was the deviation?
216.
216?
Yes.
Okay, 216. And we got somewhere over here a score of 820. And we're interested in the percent that's to the right of that. And we're going to do that by calculating the percent to the left, because that's what the table gives me, and doing 1 minus that. The only way I can use the table, this is an N 1011 216 distribution. The only way I can do this by table is converting to what type?
Can you repeat that?
There's no table for this. There's no table in existence for a 1011 216 normal. But there is one for a Z-score, which is what type of normal? It's always the same. What is it? Z-scores are always the same. Normal with what mean and what sigma?
0, 1.
0, 1. That is my Z. This is my Z distribution. So the question is, what's the center here going to be?
0.
0.
0. What's the spread going to be? Or
1.
the sigma?
1.
And what is 820 going to be?
-1.
Where do you get that from? How do you know it's -1? Yes,
Assuming that it's 1 standard deviation to the left.
You can't assume that. If it is, it is. But you can't assume that. You got to demonstrate that. How do we calculate? We know this became that, and this became that. And the question is this. It's certainly negative something. There's no question about that. It's to the left of here. But what is it? So we got to calculate our z-score. What's the formula for z again?
Z is equal x minus mu over sigma,
So what is our x?
820.
820. What's our mu?
Would that be
1011.
What is it?
1011.
1011. What's our sigma?
216.
216. Let's take out our calculator. 820 minus 1011 divided by 216. What do we get?
Negative 0.884.
Yeah, approximately negative 0.884. So, what do we do next? We share the screen so you can see the Z table that I have here. And what?
Is there no,
Sorry?
is there no like sig figs?
Well, the table only gives 2 decimals, correct? Right, this table only gives 2 decimals, right?
Yeah, I see it now.
So anything beyond that, we do the best we can. So let's find a z-score of negative 0.884. So here's negative 0.8, correct? And here's the other 8, so negative 0.88. And the next column is negative 0.89, right? Negative 0.88 and negative 0.89. If I would use negative 0.88, my answer would be this. And if I would use negative 0.89, my answer would be this. So what should I use? Because my value is negative 0.884. So
0.88,
sorry?
0.88,
Why 0.88 and not 0.89?
because it's not higher than 5. After 5, you'd round it up.
I hear what you're saying. I do hear what you're saying, and there's something to that. I would guess that this is closer, but why not take the average of the two since it's pretty much right in between?
Oh, very true. I forgot
Right.
you could do that.
So why not just take the average? We got 0.1894 plus 0.1867 divided by 2, and they get 0.18805. Which means the percent to the right is 1 minus this, which is about 87.2%. So let's see what their answer was. So when I go back and I look at the PowerPoint, their answer is 0.8127. How close is 0.8127 to what we got? Right,
Significant.
it's not bad at all, right? Our answer was 0.81195. Theirs is 0.8127. It's fairly close. Either way, we're going to say about 81%.
And 81% is the part that is not shaded, correct?
Yes, we want it to the right, so 81% is the part that's not shaded. Does that make sense? Now, who really wants to use a table? Not me. So let me show you how to use the TI-84. How many people have a TI-84, by the way?
I do.
Okay, actually, you know what we can do instead? Let's use Crunch It. Let's use Crunch It. So let's load up Sapling. So everyone load up Sapling. And let's all sign in. How do I sign in? Let's see, does this work? Sun.edu, sign in. Okay, let's go to my email because he sent me the code. Let me find it. You all sign in and I'll sign in. And here we go. Okay, so I'm in. I'm into my course. Oh, the chapter 3 homework's up. Fantastic. Due in a week, even better. Wow, I didn't even do that. Someone did it for me. Thank you, man in charge. Okay, so let's go to Crunch It. You always all know where to find Crunch It? It's the resources in the bottom. It should say Crunch It. Casio. Ooh, okay, so do you all have Crunch It? Let's see. We're gonna do the normal. Wonderful. So I'm gonna share my screen so you can follow along. Hopefully you're all doing so. And we'll learn Crunch It together. So here is Crunch It. And when I load up Crunch It, it says Crunch It, it says File, it says Edit, it says Insert, Filtering, Statistics, Graphics. And then I go to Distribution Calculator and I go down to Normal. So you should all see that, the normal distribution. And in our case, the mean was 1,011. The standard deviation was 216. And we want the probability that X is less than or equal to, no, greater than or equal to, that was the goal of the question, 820. And we calculate. Okay, and when we get that, we get 0.8117, which is very close to what we got. And out comes a nice little picture that shades the area to the right, just in case we weren't sure what we were doing. How fantastic is that? So I'm going to stop sharing now so I can see people's chat. Does anyone have a problem or a question with how we just did that? Love that, he says. It's pretty nice and simple, right? Right? Very nice and simple. A lot easier than a table and something that is always going to be there for the whole semester. And as we learn more and more things, and I've never used it before this course either, by the way, I'm learning it with you. But as we learn more and more things, we'll learn how to do it on the calc. I mean, I want you to do it without the Crunch It program. And for those who are interested, I'm more than happy to show you how to do it on this. But the truth is that Crunch It is what we're going to be using in this class. And since not everyone has a TI-84, I'd rather focus on that. Okay, so let's go ahead. Yeah.
Would you be able to upload like a video of you doing it on the TI-84 to Canvas?
Well, you know what? Let me do it quickly so you have it here because I'm recording the lecture.
Okay.
And that way you can just watch it later. I'll be quick about it. I'm not doing it for educational purposes other than you just following along later. How's that?
Sounds good.
So what I do on my TI-84 is I hit second and then the VARS key, because on top of the VARS key is DISTR in blue. So I hit second and then I hit DISTR in blue and up should pop this screen right here. And I scroll down to normal CDF because we're using the cumulative distribution function for the normal, so normal CDF. And when I hit enter, it asks me for four things: lower, upper, mu, and sigma. In our case, the lower is negative infinity. So I just do a negative huge number like negative 999999999. My upper, actually, you know what? Sorry, my lower is 820 for this case, right? We're going 820 to infinity. We want the right side. So 820. And then my upper, I just throw in a bunch of nines. 820 to a huge number. Mu is 1011. Sigma is 216. Right? So what I have is 820 to infinity, 1011, 216. I hit enter, I hit enter again. And we get the 0.8117 that we're getting all the other ways as well. Okay, so if you want to look at this later, for those of you who have a TI-84 or even an 83, which might be similar, you're more than welcome to. So now let's look at the next slide. This is slide number 21, looks like. And what we're going to do now is we're going to attack the same problem in a different way. Okay.
I have a quick question.
Yeah, go ahead.
So the first graph,
Sorry, you're breaking up, or at least you completely.
on the left side is normal. Can you hear me now?
Try again. Go ahead.
Can you hear me now?
Well, you're in and out, so I can hear you now. So hopefully it stays that way.
Okay. So the left graph behind you is a normal graph, and then the right one is the normal, the standard normal.
Yeah. So they're both normal, but that's the
Okay.
standard normal, and that's just some other normal.
Okay. Thank you.
Okay. The standard normal is specifically N01, and all other normals are just whatever they are. Okay. So let's look on slide 21. This one's a little different. It says SAT reading scores for a recent year are distributed according to N of 504, 111 distribution. How high must a student score to be in the top 10%? How high must you score to be in the top 10%? So now we're going in the other direction. Now we're saying, rather than figuring out what is 10% to the right of you, we want to know what number would give you 10% to the right of you. We want to go backwards. So I'm going to share my screen again, and I'll show you how to do it on Crunchit, because we love Crunchit now. So I'm going to X this out because it's a new case. I'm going to go back to distribution calculator, normal again. Oh, I guess this one. Okay. So what's my new mean for this case?
504.
504. So I put in 504. What's my new standard deviation?
111.
111. But this time, rather than calculating a probability, I'm going to go here to quantile. Because the probability one says, I got to fill in the number and it will tell me the probability. The quantile is the opposite. I put in the quantile and it tells me the number. So the question is, what do I mean by the quantile? Well, if 10% is to the right, how much is to the left?
90.
So I put in 0.90 and I say calculate. And it tells me that the number for which to the left will be 90%, i.e. to the right is 10%, is about 646. So if I go to my answer and I scroll down, hopefully it gives me, look at that. So they did it using a different program. They used Minitab. We're using Crunchit, but they use Minitab. And they got 646.252, and we got 646.252. Isn't that a lot quicker than, yes, you can use Crunchit when you take quizzes and homeworks. The more you use it, the better you get, and you're more than welcome to use it on any problem. And someone like last week said, hey, one of the questions uses Crunchit, and I tried to figure out exactly how, and I wasn't able to because I'm learning it myself. But yes, Crunchit, the more you know, the better you can be. Go for it. Use it for quizzes, use it for tests, use it for homework. You can use it whenever you want. So hopefully you all, how far do you round? 1 or 2 decimals. Don't give me the whole thing. I mean, 1 or 2 decimals is fine. I'm not going to be a big sig fig, you know.
I have a question.
Yes.
So,
Well, one second.
you're,
Wait, I'm sorry. Before you do that, sorry, I apologize. Before you ask, someone said, Professor, I got 99, and I'm very confused. What do you mean you got 99? So I'm going to share again. So hold on, I'm sharing again. When I go to Crunchit, okay, are you on this page right here? You have 504, 111, and 0.90. I can't read questions, but I'm going to stop sharing again. And you hit calculate. I don't know how to see your screen unless you're willing to show it.
I can show you.
Okay.
But
So,
I literally put in what you put in, and for
Okay.
some reason it
Well,
totally
wait. No, you didn't hit the quantile key, did you? Are you?
no.
You're on the wrong key. You're on probability.
Okay.
You got to be on quantile. Probability is when you have the number and you're looking for the probability. Quantile is when you have the probability and you're looking for the number. In this case, because it's 10% to the right and 90% to the left, we have the probability, we have the proportion. We want the number. So we use the other tab. Okay, so somebody was asking a question. It was Jamar, was it you?
Yes, I answered my own question now. Thank you.
Oh, well, that's great. You don't even need me. I feel so not useful. Okay. So are there any other questions on those topics that we just did? Okay, so let's take a 5-minute break. It's 4:45 right now, and my computer will meet back in 5 minutes.
Yes, sir.
Yeah.
I had to step out the room for like a minute, but I missed how you got the mean and the standard deviation on the calculator when you're working with the
Oh, the TI-84?
yeah. When
You
you're
can, watch,
using,
you can watch this video later. It'll be on it, but since we have a break now anyways, I can go over it again. Hit second,
okay.
and then hit vars. It's to the right. VARS, do you see it?
Yeah.
Now you should see a column. The second one in the column is normal CDF, correct?
Right.
Hit normal CDF, hit enter.
Okay.
Then you put down the 820 is your lower and 999999999 is your upper because you're going 820 to infinity.
Right.
And then you put in the mu, which is at 1011, and sigma, which is 216. You paste it, you hit enter, and there's your answer.
All right. Thank you.
Sure. Okay. Oh, I think we're back already, right? It's been 7 minutes. Hey, Prof, I was added to your class today. Hey, congratulations, welcome. Could you add me to your Canvas when you have time? I don't think I add you to my Canvas. I think it's automatic. It just takes like 24 hours. So it should be up. It should be up tomorrow if you got added today. Yeah. Okay. So 1 second. Okay. So let's go back to where we were. Judy.
Professor,
Yes.
sorry, I just had a quick question about the crunch it thing from before when you were figuring out the when you use the quantile.
Okay.
So the answer that you would get is 0.9. Would that be the correct answer? Because
Well,
it was
no,
when
no,
you used-
no. The answer is not the 0.9. The answer is the 646.25. The 0.9 is what you're putting in.
Oh, it would be x is less than or equal to 646.25.
Well, the question is what value will have 10% to the right? So that value is 646.25. Because 90% to the left is the same thing as 10% to the right.
Okay, that makes more
Right?
sense.
So crunch it, like most calculators, 5 minutes in Mexican time is like 20 minutes. See, 5 minutes in Jewish time is like, I don't know, a few minutes from now, you come when you want to come, no problem. So, you know, 5 minutes, it can mean a lot of different things. But anyways, quantiles is always to the left. Always to the left. Okay. So let's look now on slide 23. Slide 23 is 3 different distributions. Notice, by the way, none of the 3 are what? None of the 3 are what?
Symmetric.
None of the 3 are symmetric, but specifically what I'm looking for is none of the 3 are normal. But you're right. Actually, one of them is symmetric. No, symmetric is bad. One of them is symmetric. What does it mean?
Bimodal.
It's
Bimodal.
It's bimodal and symmetric, right? Symmetric just means it basically flips and lands on itself, right? So it doesn't have to be normal to be symmetric. It just has to be, well, symmetric. So one of them certainly is symmetric. But anyways, none of them are normal. The middle one is certainly bimodal. It's got 2 modes, 100%. The first one is skewed to the right. The last one is skewed to the left. Anyways, it says the figure displays 3 density curves, each with 3 points marked on it, ABC, ABC, ABC. At which of these points in each curve do the mean and the median fall, and explain your reasoning? So let's look at A first. So ABC, I'm going to throw in something else. Mean, median, and mode. Okay. Which of those 3 is most likely to be the median? Which of them is most likely to be the mode? And which one is most likely to be the mean? Take a couple seconds and then send me 3 letters in the order of mean, median, mode. So it could be ABC, BCA, BAC, CBA, whatever they are. Mean, median, mode. Yes.
So it's going to be the same order for all 3.
Well, I'm asking for mean, median, mode for all 3, but right now we're just doing the first graph. So someone just sent me 3 letters.
I misunderstood.
Mean, median, mode, just for the first graph.
Gotcha.
Okay. So mean, median, mode. Okay, so think about it. Send it to me. I already see some correct answers, but I also already see some wrong answers. Okay, so not everyone is correct, which is good. Some people wrote the same letter more than once, which is possible in theory. The same thing can be more than one. Nothing in theory wrong with that. but a lot of wrong answers as well. So let's go through them. First, let's do the easiest one, which is the mode. Okay, which should be the last letter. Mean, median, mode, in that order I was asking for. Mean, median, mode. So of the 3 letters, it should be the mode is the last one. So is the mode A, B, or C?
A.
A, right? The mode is the highest point. The one that occurs the most often. A, no question about it. The only question is, what about the mean and the median? So because this one is skewed to the right, the mean is pulled more to the right. And because the mean is pulled more to the right, C will be the mean. B, the median is pulled a little bit, not as much. So the answer was CBA, mean, median, mode, CBA. Let's do the same thing now for the second graph. I don't need words spelled out. I'm looking for 3 letters, right? So you could do something like this. Here, I'll give an example. This is wrong, of course, because I'm going to use the wrong letters, but all I'm looking for is something like that. Just 3 letters, A, B, C in some order, specifically for mean, median, mode for the second one. Okay, mean, median, mode. Ah, good. Someone noticed a slight problem. Me, good. I love it. Fantastic. Some people are noticing that 3 letters just won't cut it. So there are 2 modes. This is bimodal. That's correct, Brielle. It's bimodal, 2 different modes. So some people got it. The answer should be, of course, I was very specific how I wanted it, so that was my bad. But the best answer I saw was something like that, either with commas in between or a separation. The mean and median are both B, because it's symmetric. They're both directly in the center. And the mode is both A and C. So yeah, B, A, C was actually probably a better way of doing it. And that was my bad. I didn't really look at it before I said how I wanted it. Why would I send a private? I don't know private. Oh, you know what it is? When I receive a private, it automatically reverts to response. Well, that's weird. So yeah, something like BBAC was great. And then let's do the same thing for the last one. This one, no trick question here. So mean, median, mode in that order. Mean, median, mode, go ahead. So yeah, everyone who answered so far looks good, I think. ABC, 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 ABC. Well, some people said BCA, BAC, someone said. Remember, the mean is pulled more. So the mean is further, mean is A. Median B, mode C, ABC. Okay, let's look at slide. What slide are we on now? Slide 24. What's coming up here? Hold on, let me just scroll down a little bit and see what's coming. Oh, lots of questions. Okay, this is great. We're almost done. We're almost done. Okay. This is a great one. We're gonna skip 3.7 only because of time, but I want to do question 3.8 on slide 24. It's a great example of the need for standardization. It says in 2015, when she was a high school senior, Linda scored 680 on the mathematics part of the SAT. That was normal with mean of 511 and deviation 120. Jack took the ACT. Also normal, but with mean 20.8 and standard deviation. Oh, and what the hell?
Which slide number is this?
I'm on slide 24, and whoever wrote this kind of screwed up a little bit. But it looks like he scored 26 when the mean was 20.8 and the deviation was 5.4. And the question is, who scored better? Linda scored 680 on a normal 5'11", 120 distribution. Jack scored 26 on a normal 28.8, 5.4 distribution. And the question is, who scored better? So how would I answer the question? Forget about actually doing it, but how would I answer the question for who scored better? Anyone? How would I answer the question, who scored better? How do you compare two different z-scores?
Wouldn't you have to standardize both of them into one fluid?
That's correct. So let's standardize. How am I going to standardize those?
Like mean minus the standard deviation and divide it.
Yeah. So we can do it that way. Or we can use Crunch It. So let's use Crunch It. I'm going to share my screen. I'm going to share my screen. Hit the wrong button. So you all see Crunch It? Yes?
Yes.
Yeah.
Okay, so we go to probability. Let's see. Linda scored a 680 when the mean was 511 and distribution was 120. So when I calculate, so let's do less than or equal to instead. So she scored in the 92nd percentile. Her score was better than 92% of observations. Do you all see that? Mean, deviation, how many are less than her? 92%. Correct?
Yeah.
Okay. Meanwhile, Jack had a 20.8 mean, a 5.4 deviation, and he scored a 26. So what percent scored less than or equal to him? Oh, 83%. So who did better, Linda or Jack?
Linda.
Linda, right? We standardized, we computed their probabilities. I mean, Crunch It did it for us, so we didn't have to do all the steps. Was it a lot faster using Crunch It, or would it have been better doing it by hand?
Crunch It.
Crunch It's a very powerful tool, right? So use it as much as you can. Okay, now it says find the standardized scores for both students. We did not actually do that. Crunch It just went ahead and got the answers for us. If I want these standardized scores, that would be taking her score, which was 680, minus the mean of 511, divide by 120, and Jack take his score 26, minus the mean of 20.8, and divide by 5.4. Does that make sense? Questions on that? Okay, the rest of this PowerPoint are some great questions. It's all just lots and lots of normal calculations. There's nothing new. It's just lots and lots of questions. Almost like a quiz or a test. Wonderful. So why don't we just do one at random, or a few of them. Let's turn to slide number 26. We all on 26? Yes?
Yes.
Okay. So 3.15, which of these variables is most likely to have a normal distribution? In other words, we expect lots in the middle, not a lot in the lower, not a lot in the upper, right? To taper off. Is it income per person for 150 different countries, sale prices of 200 homes in Santa Barbara, or length of 100 newborns in Connecticut? Which of them do we expect to have a normal distribution? Proof that girls are better. I think she was referring to the previous example, and I'm not arguing that whatsoever. I don't know if it's proof that girls are better, but it certainly indicates it, that Linda was better than Jack. I'll give you that much. But anyways, this one, the answer is C. Natural occurrences are much more likely to be normal than unnatural occurrences. Lengths of newborns, we expect the majority to be near average and not to have a lot that are very tall. How many war zone wins did Linda have? I believe she had 14. That wasn't given in the problem, but I meant 140. Is that good? Is that bad? 14? I don't know what, someone said weak and now someone else says wow. I have no idea what they are. I don't know what a Warzone win is. Is it some kind of game? Was it Minecraft or something? Huh? Did I?
Exactly.
Is it really? Oh, Call of Duty. I've heard of these things, but I've never played them. I used to play a different game back in the day. I don't even know if it's around anymore, but your games I don't play. So don't get time. What game did I did not play Pong? What the hell, man? How old do you think? Okay, you know what? You just failed. You just failed this class. Pong. No, I played a game. It was called EverQuest. This was back in 1999, 2000, 2001. It's like some 20 years ago.
Have you played Wizard 101?
No, I haven't played a game since then. It's
That game is still up and running.
Is it still up and running? 20 years later? Crazy. Crazy, but that just shows you how amazing the game must be that 20 years later it's still going on. Unlike these fad games, they come and then 2 years later they're gone. Right? Minecraft, is it even still around? No, of course not. It's over, right? I don't know. I'm just guessing. Okay, next question. To completely specify the shape of a normal, you must give A, the mean and standard deviation, the 5-number summary, or the median and the quartiles. Is it A, B, or C? It is A. And mu sigma, all you need, mu sigma, mean and standard deviation. If you're saying the 5-number summary or the medians of the quartiles, that's not right. Those have nothing to do with normal. Normal is mean and deviation. 3.17, the figure on the right, 3.15 shows a normal curve. What is the mean of this distribution, 0, 2, or 3? Zero, 2, or 3. It is B, 2. For a second, it was kind of hard to see whether it was 2 or 3. So then I used a little trick. I saw the left edge was -8, the right edge was 12, and the center has to be the average of those two, which was 2. What is the standard deviation of this curve? Is it A2, B3, or C5? So A, B, or C. Let's see what people say. This one's a little tougher. So we know the center is 2. So I kind of, you know what, I'm going to share my screen for a second so I can show you my logic here. So you can see what I'm talking about. So I took the center, which is 2. And then I said, okay, if the deviation is 5, that's 7, which is here. And if it's 3, that goes to 5, which is here. And if it's 2, that goes to 4, which is about there. And I decided that for 4 is certainly not right because past 4, it still looks like a hill. So 4 is out. And 7 can't be right because past 7, it's still a little bit looks like a bowl. So it looks like this one is a hill to the left and a bowl to the right. So therefore, the distance is 3, and the answer should be B. That's how I did it. So makes sense, right? Okay. And the next slide actually has the answers to all that. C, A, B, and B. I was correct. Fantastic. Okay, so are there questions on this idea? What time is class over? We go 4 to 5:40? Is that what it is? That's crazy. I thought we were done. I was like, oh my God, I can go take a nap, but apparently I can't. Let's go to the next slide. This is slide number 28. Because this is all, I appreciate that. Yeah, I can if I want, but this is important enough to really, really, make sure you have down. So let's look at the next graph. The next graph is, next slide I meant, says 3.19. And I want you to use Crunchit for this. It says the distribution of hours of sleep per week, night among college students is normal with a mean of 6.5 and a deviation of 1 hour. So it says what range contains the middle 95%? Is it 5.5 to 7.5, 4.5 to 7.5, or 4.5 to 8.5? So this is a little different than what we did. So I want you to think about it and then use Crunchit to see if you can figure out the answer.
Which tab is under?
Well, let's think about that. The regular tab is when you have the numbers and you're looking for probability. The quantile tab is when you have the probability and you're looking for numbers. What do we
Right.
do? Huh?
I'm asking just how to get to that point from having Crunchit open.
Oh, hit the distribution calculator, which is the last little tab, and go down to normal.
Okay.
Right? And I'm not gonna even look. I'm just gonna, look away, and I want you guys to try to do this. See if you can figure it out. It's a little different than what we did, a little more sophisticated, but you guys might be able to do it. You should be able to do it. So I have a few people say one answer, which could be right. I haven't checked. But it's not so much what the answer is, it's how you get it that I really care about. So even if it is correct, I really want to make sure that you know why it's true. So most people say one answer, but I have a few who said each of the other possible answers. So here's how I would do it. I'm going to share my screen. So here's my screen. So first of all, what's the mean in this case?
6.5.
6.5. And what's the standard deviation?
1.
1. Now, if I want the middle 95%, that means where am I going to be the cutoff point for the outside of that going to be? What percentile? First of all, it's going to be a quantile because I have probabilities. Where is the cutoff for the middle 95% going to be?
2 deviations.
Nothing about deviations. I'm looking for an actual value. No. Well, yes, you're right. Sorry. Oh, that's how they wanted you to do it. Yeah, that makes a lot more sense. Oh, of course, that makes it easy. I wasn't even. I'm tired. That's right. But I was thinking as a quantile for the middle 95%, 0.975. But yeah, if you did it that way, that's so much smarter. Because that cuts off 2.5% on either side, correct? So if I do the middle, so if I do that, that gets me 8.46 or 8.5. And on the other side, for just 2.5%, that gets me 4.5. But yeah, now that I think about it, why 0.975? Because the middle 95% cuts off 2.5% on either side, correct? 2.5% on this end and 2.5% on that end, right?
I also have a question. Why 0.975 and why not 97.5?
97.5% is 0.975. Remember, we're dealing with percents. 97.5% is 0.975. You see what I'm saying?
Yeah.
Okay, so, but the easier way, the much easier way, is recognizing that the middle 95% should be 2 deviations in either direction. So down 2, up 2, so 4.5 to 8.5. Much smarter than how I was doing it. I was just so in crunch it mode that I wasn't even considering the easier way of doing it. Also, the percentage of students that sleep at least 8 hours per night is about what? At least 8 hours per night. So this one, let's use crunch it for. At least 8 hours a night. Let's use crunch it for this one. So let's share the screen. And we're going to use crunch it. We want at least 8 hours, correct? So this time we have the numbers. We want greater than 8. And we calculate, and it gives me 6.68%. Was that one of the options? 6.7% right there. Does that make sense?
Yeah.
Okay. Then it says, so go ahead and do the next question.
Wait, I'm sorry. What was the answer?
6.8%. Do you see why it's 6.8%?
Yes.
Okay. So the next one says the proportion of observations from a standard normal that take values greater than 1.78 is about what? How do you do that one?
Use the P is.
I'm sorry?
Would you use P is greater than 1.78?
Yeah. So let's go back to crunch it. And we have, first of all, it's the standard normal. So what's my mean going to be?
$6.5.
Standard normal. What's my mean going to be?
0.
0. Deviation is going to be what?
1.
1. And I want greater than what number? I forgot what the question was.
1.78.
1.78. So greater than 1.78. Go right to crunch it. What does it give me? 3.75%. Was that an answer?
B.
Yeah, there we go. C, 3.75%. The proportion of observations from a standard normal that take values between 1 and 2. How am I going to do between 1 and 2? How am I going to do that one?
Would you take the 2 values and subtract them?
Well, what 2 values? Like 1 minus 2, 2 minus 1? Is that what you mean?
So stuff greater than or equal to 1, and then stuff any numbers lower than or less than.
Well, so here's greater than 1. Right? Ryan, are you talking?
Yeah.
Okay, so is this what you wanted, greater than 1?
Yeah.
Okay, what do I do with that?
I guess you would take those numbers and then write it down, and then do all values less than 2, and subtract those 2.
Well, that's the problem. If I do greater than 1, then I have this, correct?
Yeah.
And if I do less than 2, then I have this, right?
Yeah.
But there's parts of this, parts of the first one that I don't have now, and parts of the second one that I didn't have then. So it's not.
Wouldn't you take what's greater than 2 and subtract it?
So greater than 2 gives me that.
And you would subtract that from whatever is greater from 1 to get between 1 and 2?
That's how you do it. So this is 0.02275. 0.02275. And the other one was 0.15866. So when I subtract them, what was the other one? 0.02275, right? And 0.15866. When I subtract them, I get 0.13591. 0.1, and there it is, 0.135. Does that make sense?
How did you do that again?
So here's what I have. I want between 1 and 2, right?
Yeah.
So crunch it can do to the right of 1. It can do to the right of 2. So if I want this part, that means take everything to the right of 1 and remove everything to the right of 2. So whatever number I got for bigger than 1 minus whatever number I got for bigger than 2, and that will be between 1 and 2.
Got it. Thanks.
Right, so sometimes, I mean, the TI can do between 2 numbers. Crunch it, unless there's a part of crunch it that I'm not familiar with yet, because again, I am learning it like you guys are. It seems that it can only do bigger than or less than. I have not yet seen crunch it do between. If it can, I don't see it yet. But it's good because it shows us that even when you have the calculator to do it for you, that doesn't mean that you can just stop working. You still have to know what you're doing. Okay? Make sense?
Yeah.
Yes?
Yeah.
Okay. So the rest of it's pretty redundant, same thing. Okay, so let's stop here. Let's stop here. Yeah, okay, I'll stop recording.